Well, hello everybody, and welcome to Skyter live stream for Thursday, the 15th of September, this 2022. We are lucky that we can stream tonight. I didn't know that we'd be able to. I thought maybe we would be unable based on our schedule for tonight and today, but that's fine. The wedding tomorrow between my son and his lovely bride Kelly is taking place at 3 in the afternoon, so I have plenty of time to sleep in the morning if I need to. And once I realized that, I figured I'm gonna stream for you guys. I'd love to just keep on going. I guess it's a sickness. Hi Izabela, hello Hedrick, how are you? Daisy and Zoe are with us. Daryl's with us too. Let me bring him in. Daryl, how you been?
Oh, Mark, I'm good. You?
Great.
Good. Hi, everybody.
Yeah, and Wayne Pinkham is here. Wayne just came over the other day, and he brought me the coolest T-shirt I've ever had. It was from Mauna Kea. He got to the ranger station, and he got me a T-shirt that said Hawaii or Mauna Kea observatories, and on the back, it had images of every single mirror on the mountain and their sizes. Really cool shirt. And I want to give Wayne kudos for that because I want to thank him. He also brought me this cool Oumuamua postcard from there as well. It was a very kind-hearted guy. I've known Wayne for years as a radio control flyer with me here in Connecticut. And we kind of lost touch for a while, but Skyter live stream has kind of brought us back together. I thought that's pretty cool. So once again, publicly, I want to say thank you to you, Wayne. That was a really nice gift.
I have a water bottle from Mauna Kea Observatory. Plant manager where I used to work, he married a Hawaiian girl, and they were over there on vacation or visiting, and he evidently went there and got me one of those big Nalgene water bottles, you know? It's got the logo on it and everything. It's really cool.
That's cool. Yeah, and the T-shirt is wonderful. I wore it just the other day. I mean, I told Wayne, and I meant this, that this is by far the coolest T-shirt I've ever owned. and I told him that multiple times till he got sick of it. But anyway, I want to welcome everybody here. Tim F is with us. And I want to get to the top. Hedrick was the first one. Nice job. And then Robin Curtis is right behind him. And we have Cosmic Ray. What's up, Ray? Nice to see you. And then we've got Papa Tom is with us tonight. That's fantastic. Good to see you, Papa Tom. Bullwinkle is here with us. And he'll pull a nebula out of his hat for you. And let's see. It's still early, but we're gonna pick up a lot more people, I'm sure. And that's it. Besides that, I think we're covered. I don't see anybody else. If I missed you, make sure I know it. Anyway, what you see on the screen right here, I'm 2 images in to a 4-image mosaic. This mosaic is of the Trifid Nebula in Sagittarius. Then next to it, this area here, which is just above the Chinese dragon. Then we're going to go down and do the Chinese dragon now, okay? And then go over and do the lagoon. We're going to have that 4 panels. And we're going to put those together and make a mosaic. So now I'm at the point where I'm guiding, and I'm going to take the next set of 45-second exposures. All right, and we're going to do that now. And get out of our night vision mode and go into the live stack. All right, that's the last one that we took. This is the top of the Chinese dragon, and I moved it all the way up here. So now we'll have the whole Chinese dragon in here. All right, so we'll clear this now, and it's been saved under the composite name up here. And so I did 2 of them already. So I'll change the name again just one more time. There we are. So, and after we do this composite, if you guys have requests, feel free. Hello there, M. Turner. How are you? Nice to see you. Okay, now let's, this is going to be the Trifid Chinese Dragon Lagoon Nebula Composite. And these are wonderful hydrogen emission regions. Places where stars are born. Stick that out there. There's a name for you. Hey there, Legless Lex. What's up? We have some asteroids out there, and when the time is right, I think we're going to be able to spot them and watch them. You'll actually be able to see them move in the field, which is kind of cool.
Yeah. I don't know if I ever mentioned to you, Vesta was at opposition just recently. That might be a good target. And actually, it was down there pretty close to the Helix Nebula, too.
Huh. Well, the Helix is going to be coming up here in a bit.
Yeah.
That prime viewing location. Oh, thank you for putting up the link. That's the link to this location here. SkyTourLive.com will take you to that link that Daryl put up there. SkyTourLive.com is our one-stop shop where you can go and actually check out a gallery of everything we did. You can also go to the actual data folders, which is what Daryl put the link up to there in the chat. And you can also order prints if you like on canvas, on metal, and photo paper. It's just amazing. So we're trying to make it a one-stop shop for all of your astronomy things. I can't say too much, but it looks like we're getting a second telescope for the building, and it's going to be a telescope that's going to do higher power stuff. So if we're looking at this object right here, for instance, okay, we're going to be able to see not this whole screen amount, but like this little amount. We're going to be able to zoom in and be able to see much closer. I'm going to pull the name out here because now that we know it's a composite, I can just remove that. Yep, and we will be doing the horse head, yes. Hedrick. The horse head is gorgeous. The way we shoot it, it's amazing too, because in just a few seconds, we can see all this amazing detail. This is a 45-second exposure, you know. Now, I admit we are under phenomenal skies. Let's see if I can show you those phenomenal skies. The moon is not up yet, and we're chasing the moon's chasing us, but we're trying to keep it out of the limelight here. Let's see if our camera will connect. This I have to troubleshoot this too when I go out there, but it worked yesterday, so maybe it'll work tonight. Hey, look at that! It worked. So. That's only an 8-second shot. So let's change that shot to a 12-second shot. Well, let's go to 15. That's 15,000 milliseconds. Not 25,000. That looks good too, but we'll do 15. Okay. And we'll go back to our preview and do a single acquisition. And just to give you an idea, while we're still going, here's the Milky Way. It's a gorgeous night. Gorgeous night. Jupiter rising.
It is.
There is Vega and the constellation Lyrae. This is Cygnus, the Northern Cross. You can see the Northern Cross right here. And this is Altair. And together these three stars, Deneb at the top, actually the tail of the swan, and the part of the harp called Vega in the constellation Lyrae and Altair, these make the summer triangle, which is over your head right now at sunset. Alright, that's it. And that's Arcturus out there from a season gone that's past. This is the Big Dipper right here. If you notice, 1, 2, 3, 4, that's the bowl of the Big Dipper. And this is the tail of the Big Dipper pointing at Arcturus. The two end stars in the bowl point to the North Star. And the North Star is right here. That might be the North Star. This is the North Star, sorry. No, that's the North Star right there.
I think North Star is the next one over to the right.
There?
Yes.
In the Milky Way?
That depends on how far true north is in your camera view.
Well, I think that this right here is the north, is Polaris, because if you notice, it comes to the Little Dipper right here. So there is the North Star, and there's the Little Dipper.
Okay. Yeah, the two stars there.
Yep.
Kochab and Furcad, they're the front
Yes.
of the Dipper, the Little Dipper.
Yep.
Alrighty. My bad. I'm a bad
No
astronomer.
worries. No, you're not. Not at all.
Yeah, I am. I'm a bad astronomer.
It's hard to read a warped view, you know. Okay, so there you go. That's
a astronomer.
Yeah. All right. So we are at 8 or 9 rather. Look how beautiful this is coming in. This is the Chinese Dragon Nebula, and we have we have a whole panel like this above this that we took, a whole panel to the right that we took, and what's left is the Lagoon Nebula itself to the right. I saved the best for last. Yeah. Oh yes, Cosmic Ray. You asked about the Epsilon Lyrae. Absolutely. I'm. After we do this composite, don't let me forget. Put it in all caps if you have to. If you want to talk to me and get Daryl's attention too, you know, I know you don't. People they say don't put everything in caps, but if you're asking a question, do that, because that'll be very, very helpful. You can also put you know, the Skytour live stream label in there too. It'll blast out in orange and we can't miss it.
Yeah. Hedrick, I think it was, asked about saying Messier 5 also.
Globular cluster?
I'm sorry?
Globular cluster?
Yes. It's in Sherpins.
Yeah, it's up
after
there.
you finish the lagoon, you might want to pop up and catch it before it's too late.
Okay, and then we can go to Epsilon Lyrae.
Okay.
Okay, we're at 10 here. I always find myself like bopping to this music. This is just so much fun, let me tell you. I always get a kick out of opening a telescope 2,500 miles away and getting this type of imagery in seconds. It blows my mind. Blows my mind. We're working on the final exposure here before we go to the lagoon. It'll be this guy here. Let me throw it back out there for you. That's Chinese Dragon, Trifid, Chinese Dragon, Lagoon Nebula Composite. These are hydrogen emission regions. Alright, let's pull those out so that you don't lose track. Okay, now we get the 12.
Did I hear a cork pop a second ago?
I just went.
Oh.
Yeah. Okay, so there we go. Now I can save this exactly as seen. And then I will save it.
I thought you were getting a head start on the wedding.
Oh no, not at all. He's here actually. He's sleeping here tonight, just to make it easier for everything. It's only a few miles away. This is all happening. All right. Okay, so that's done. Now we have that one up there, so that'll be up there ready to go. And now what we're going to do is move this over to pick up the lagoon, and we'll catch these stars here. We're going to put on this edge, and then that'll leave a perfect composition with overlaps, so we won't have any gaps. I know when you make the Hubble images, they have gaps. We're going to try to avoid that. Okay, so we're going to come out of here now. We'll clear that after. And we're going to go into, check this out. Watch, let's how much extra detail is there if I maximize this. Let me do that.
I think you caught a globular down there in the bottom right hand corner.
Yeah, that you'll see that. That's the one by the lagoon. Okay, here we go. Alright, we're in night vision mode, so now we're going to move ourselves over. We're going to move to the west, so we're going to take these stars and put them over at the left edge. And you'll see the lagoon coming here very shortly. You can already see its nebulous detail coming in. Here we go. Mm-hmm. Okay, a little more. Okay, a little more. Okay. This might still leave us with a little bit of a gap, but at least we're going to have coverage throughout the whole center. And we can crop out a little bit that might not be quite right. Okay, we're going to wait for our search to resolve into guide stars. There we go. And then we'll come back and do a 45 seconds right here and start that. And then go into our live stack and clear the last shot, which is here. So these stars we put over here on the left. And we'll clear this now. You'll notice tonight we do not have any of those errant pixels like we had yesterday, little white spots that just kept persisting. So tonight we're doing well. The sensor is at minus 10 degrees Celsius. So we have a perfectly cooled sensor. It could go to minus 20, you know. I choose minus 10 because I don't want to overload it in the desert heat and make it work too hard because that might shorten the life. Yeah, there we go. That is a beautiful object. Let's see. Let's go to auto on that. Okay, so there's that globular down there that Daryl was talking about. Just to this side, this is where the Chinese dragon is out here. And just out of shot, right about, well, you can't really see my cursor, but just about an inch up that way is the Trifid Nebula. And this looks like it's resolving well. Oh, yeah. This, the seed of life in the universe, you're looking at it right now, guys. This is where it comes from. Actually, realistically, where it comes from is in these dark areas. This right here, this globule, that's a gravitationally collapsing globule. Okay. Most likely. Then you have things like this, a gravitationally condensing globule that's got streaks of material that is wafting away from it. So there's stellar winds from stars that we may or may not be able to see that are pushing this material away and sculpting the space around it.
Good thing they didn't call them boogers. Bach boogers has a kind of a ring to it.
It's what it does. Yeah. Yeah. And down here, another gravitationally condensing area here. And all throughout this. Now, these clouds are areas where the radiation may penetrate to some extent. But there's definitely hydrogen gas in here. Like this area right here. This is a lot of dust in here that you're looking at. But there's also hydrogen that is also illuminated because it's glowing from being ionized by the hugely bright O star that's right here. You can't see it unless we take advantage of our massive dynamic range on this system to show you that little hourglass-shaped point in the middle. There's an O-type star, the hottest and bluest star the universe has. And it's right in there. And it's causing all of this to glow. Not bad. And then you have these hot young stars that have burst on the scene. All right, from the same gas, and this is causing this to glow, and then these are ionizing other gas out here. So it's just an ongoing process. Hello, Judy McClelland and Luciana. How are you? Nice to see you guys. It's always nice seeing new faces out here. And in case you're wondering what you're looking at, for those that have not seen, this is the telescope control system up here. We have north, south, east, and west, and coordinates to get into the telescope computer right here. This is the telescope in the building live. This is the camera view live, and that is the camera control cluster over there. And this controls our stack. We're actually taking image after image after image and aligning them automatically and stacking them on top of each other to make a final image. And right now we've stacked 5 images in here, and look how beautiful it looks already. We're taking advantage of the fact that the moon hasn't risen yet. It's going to rise in another hour out there, maybe a little more.
I wouldn't be surprised if it was less.
I think it's 9:17.
Huh?
I think it rises at 9:17 out there.
Okay.
And it's 8:24 out there.
Yeah. Oh, this is the time of year of the harvest moon.
Yeah.
Well, you were asking about seeing zodiacal light this time of year before we came online, and this time of year in September, the plane of the ecliptic makes a shallow angle to the horizon in the east, and so the full moon and before and after a few nights on either side, the moon appears to almost hover in the same place. It rises in less than in a relatively short amount of time each night because of that shallow angle of the ecliptic to the horizon. And they call it the harvest moon because of when that happens, the farmers could go out and they could work after dark every night.
That's right. They could see.
Harvesting their crop.
This is beautiful. This is such a beautiful area of just dust and ionized hydrogen that's glowing. My gosh, it's really, it shows you the complexity. This section of the universe is really filled with lots of debris from previous supernovae. That's what all this dark area is. This dust created by massive stars as they go supernova, and regular stars like our sun as they die off. It's really amazing. I did notice a little wind out there, so we will do our best to try and mitigate the problem. But look at this beautiful image. Wow. Yeah, we got this little artifact sticking up again. See that? I'm not sure what that is.
I'm sorry, I was looking away. What are you talking about?
See this little light artifact?
Oh, yes.
That showed up before, and I'm not sure what that is. Remember, I thought it was a cloud. I don't think we have any clouds. I'll do another acquisition here. If the camera's still connected, we'll see.
It must be real.
Oh, it's real. But it's not something in the universe. It's actually something that's getting in our way. Okay, so there you see that. You saw how much the Earth rotated. And we're actually looking down here. There's the Sagittarius star cloud down there. I think we got a little tiny drifting cloud that came through and did that to us. That's alright. It's not harmful. We can get rid of it.
Vaguely make out the upside down teapot there in that view. That brightest star there.
That's Antares there.
Yes.
And then this is the teapot right here, I think.
Yeah, up a little higher. That
Right
brightest
here, right?
star is Nunki.
This one?
No, over to the right.
This guy?
No, to the right. That
You mean
star.
here?
That star is Nunki. That's the
Oh, that's the top of the
outside
teapot.
upper star in the handle of the teapot.
Okay. Okay. Yes, because it's pouring the Milky Way. Gosh, this is beautiful. This glow, by the way, is a very sensitive camera. You can see the lights of Phoenix 65, 70 miles away here. But to your eye, they're just not visible. But the sensitive camera that we're using can see that. But notice how dark everything else is. It's a beautiful dark sky out there. It is. I think it'd be helpful if I kind of get rid of this. So let's do that. I'm pointing stuff out. Here's W of Cassiopeia right there. Right. Let me show you again. 1, 2, 3, 4, 5. There's a beautiful little nebula right here, but we can't see down that low yet. We have to wait just a little bit. The building allows us to see kind of in this range right now because it has walls. Okay. Izabela says, could it be light from a building somewhere near the telescope? Nah, the only thing I can think of, it might be a security camera that gets tripped on occasionally. The property owner could be turning it on, and of course our system's very sensitive. It might see that as stray light, even though it's shielded from it entirely. Still, it's really not a big deal. Okay, let's bring that down and go over here, check out our stack. We're going to pause it there. Save our final composite. Let's gotta name that first. Alright. It'll be composite 4. And then we'll save it. It's saved out there. Oh, Izabela's going to have fun with this one. Izabela, you're going to take all of those and you're going to stitch them all together. And with the tool I showed you how to do it, you could do it in about 30 seconds. Put all these pictures together. In fact, you can have it done before we're even done with the stream. Okay, so we're done with this composite. Now, while we're here, we might as well go look at M5, correct? Because that was a request.
And Hedrick just left.
He did?
I think, yeah, he said he's dinner, but I'll keep it on in the background. Be right back. Maybe he'll come back while we're looking at it.
It's okay if he watches it later. We'll see it.
Okay.
Okay, sorry about that on your big screens if you're using big screens. Okay, and let's go into our view here. Just love this. Okay, now let's go and open up our planetarium. This is the other view we have, which allows us to go around the sky. We actually have a nice planetarium that controls a telescope. It's a controlling system called Stellarium. Stellarium is a free product. All right. Okay. So now we'll go to Measure 5, and we can do it by just doing this. Say, is it M5 going to do it? Yeah, right there. Oh, that's really low.
Yeah, that's what I was afraid of.
Yeah.
That's in the western part of Serpens.
Yeah. Yeah, it's too low.
Yeah.
Hedrick, when you come back, I'm sorry. Well, thank you for that suggestion. If we had gone when you said it, it would still have been too low by then. So sorry about that.
Geez, that's almost in the west now.
Yeah. Okay, so let's see now. I have... Oh, you know what we can look at? Well, we could look at Measure 22.
Sure.
Okay, this will be a globular cluster that's visible to us. So let's go check that out.
You see all those yellow circles with crosses in them, those are all globulars.
Yeah.
This is
Okay.
part of the sky where you'll find the most globulars.
And correct me if I'm wrong, but wasn't it you that told me that if we had, if this cluster was a little higher in the sky, it would compete with Messier 13 as a brilliant
Yes.
object?
Yes.
Yeah. Okay, so we're going to a nearby star, and it's going to be Caus Borealis. There's a globular right there, as a matter of fact. Caus Borealis, this is in Sagittarius as well, is it not?
Yep. Top of the teapot.
Oh, and here comes that could be a Starlink satellite.
Also the northernmost star in the bow of the Archer, which is why it's called Borealis.
Okay.
Caus
Well, obviously
Borealis.
that's something there. That is our beautiful Messier 22. All right, we're gonna just slide it to the west a little bit. Center it up. Let's check our centering, shall we? Okay, well, that's good. That's good enough. All right. Okay, we're gonna let it catch our guide star, and then we'll take a few shots of this. And now that we're done with the composite, I will label this as Messier 22. And it's a GC, a globular cluster. Alright. We're guiding, and let's do a 30-second shot. It'll capture everything and too much of it for sure. Okay, we'll start it again because I don't want to have that in there, so we're going to make it I'll do 25 seconds actually. Alright, so clear that, go into our stack, and you'll see the dynamic range. We're going to be able to either see lots of stars on the outside and whittle it down to look at all the stars in the middle. That's what's beautiful about this sensor. It has very high dynamic range. Thank you, Cosmic Ray. Ray says the M22 diameter width across is 99 light years approximately. I'm not sure of that. I'll have to see. There we go. Look at that. It's in the middle of a very, very healthy amount of stars already. And let me put this on zoom so I can move it. There we go. So now watch. You see how the center's blown out, but if I do this, I move our mid-range, we can get it down to just those central stars and make this cluster a very, very different place. Look at that. Isn't that cool?
You talk about all the stars in the field. If you look at Stellarium, I believe you're in the large Sagittarius star cloud now.
We are. I'm going to clear this because we had a mild guiding error, so we're just going to let this come in. This next one might be fine. It probably started too soon. Let's find out. And there's also some wind, I did notice. Okay, now you notice this is a lot better. Look at that, right to the center. See, there's like a bar here, this empty area. This is just kind of like line of sight issues with the cluster of stars, the way they're distributed. There's very little gas and dust in these original objects, and I call them original because they were among the first created in the universe. They were made with the first stars. Basically, they're the oldest stars in the universe, generally. You know, and that's, as Cosmic Ray's pointing out, they are metal poor. Well, in terms of astronomy, a metal is anything above helium. So you have hydrogen, helium, and everything else when it comes to metal and non-metal stars. Yes, neon is not a metal, but it's a higher proton count element. It has, a higher atomic weight. So mostly hydrogen and helium in these stars. What does that mean? it means that we probably don't have very many planets in globular clusters at all. It's romantic and wonderful to think about that, but a planet can't really be made there because there's no material to make it.
Pity. Be a hell of a
No.
view from in there.
I know.
And when you say metals, anything heavier than helium, I mean, the next element is lithium, correct? Which is a metal.
Well, yeah, but I mean, if you keep going, you've got calcium.
Yes.
It's not a metal.
Yeah.
Carbon, not a metal. Oxygen,
Calcium,
certainly not a metal.
calcium is a metal.
Well, it's a is
Same
calcium a
family
metal?
as sodium, lithium and sodium, calcium and magnesium. All the IUMs are metals.
Well, I thought that. Are you? Oh man. Okay, mental brain fog, I guess. But you don't have like neon, for instance, isn't a metal; it's a gas. Oxygen's a gas. So we're not, So when we talk about metals, we're talking about elements that are not made in the cores of the stars for sure, but also that can't exist because they never did exist yet when these stars are made, and they're not going to make them.
Izabela asked a good question. She said, Mark said there are not many planets. Does it mean there are some planets? And this brings up something I think you mentioned recently, that
Yeah.
as the globular travels through the galaxy, as Ray
right.
said, it's 10,000 light years away or so inside the galaxy, that it may well have captured stars from outside the cluster.
Right,
And
or release stars from inside its cluster.
Okay.
Yeah.
Maybe those stars had planets with them.
Right, and if we ever see a star, for instance, that goes supernova in a globular cluster, then perhaps it's because it was a captured star caught when the cluster was coming through the galactic disk. This is a high concentration. This is a high gravitational concentration. So these stars are all interacting with each other. In physics, we have something called the n-body problem. All right, and that's like trying to figure out the physics of multiple bodies all working, all interacting with each other. Really, really, really difficult problem to solve. And so when we talk about it in terms of a globular cluster, we are talking about 50, 100,000, 500,000 stars or more. Some clusters have even more. And they're all gravitationally interacting with each other. Isn't that crazy?
Mm-hmm.
So that's pretty crazy.
Ray mentions that there may be 2 black holes in M22. I have read of black holes inside globulars occasionally.
Mm-hmm.
Perhaps they were captured objects.
Maybe. It's possible. Or perhaps black holes are the seeds
Perhaps.
for globular clusters.
Yeah.
That's something we don't really know. Look how beautiful this is. This is an exploding snowball of stars. Let's pull that. Let's move this out of the way for a second. Look at that. And let's hide this right here. Look how beautiful that is. Wow.
Izabela, some people think that since globulars are some of the oldest objects in the universe, that they may have helped form the first galaxies.
That's a theory. Yeah. Yep. That is definitely a theory. That might be true. Okay, this is Messier 22 globular cluster.
Long been one of my favorites.
Oh yeah, you go out there now. There we go. Hi there, Donald Kunzer. How are you? Let's push that up a little.
Every globular is
Wow.
different, and each has its
Yeah.
own character.
This is.
Some are,
I'm sorry. Go ahead. You finish your sentence. I apologize.
well, I was just going to. Some are looser, some are tighter, some are very compact, some are spread out, some are bigger, some are smaller.
Cosmic Ray, you're saying M22 is one of only 4 globulars of our galaxy. Actually, I'm not sure how you define of our galaxy because we have many, many globular clusters. When you say of our galaxy, define that. Because I don't know of any astronomical definition that could fit in.
I want to say there's 150 or 200 globulars in the Milky Way.
Maybe more that we can't see because we're out of our line of sight.
Yeah.
Hey, Danny Johnson. How you doing, man? Good to see you. Thank you for coming. This is a globular cluster, Measure 22. I've gone full screen, and I'm going to pull back now so I can check out the telescope right up there in the building. Oh, that looks really pretty. Man alive. This is live astronomy, too. Let's jump right in here, shall we? Look at this. Huh. Look at that. Yeah.
Would be a shame if there were no planets in there. That nobody could appreciate the view from inside, you know?
Yeah, I mean, the stars are separated by a pretty good amount. But the difference with the globular cluster is they're evenly spaced. Like we see a cluster here, a cluster there, a few concentrations of stars, the Milky Way. In there, you're going to have evenly spaced stars pretty much all around. There'll be some clustering here and there as they make, clusters over the millions of years. But then they just move on and keep moving around each other. Izabela, I want a globular cluster for Christmas. Well, you know what, Izabela? You could get this one enlarged and printed if you want. That's a cool one. Hey, Taryn Marie. Thanks for coming.
Maybe we could make somebody could make a globular cluster snow globe.
That'd be kind of cool. Wow, okay, we've got probably quite a lot of these done here. We've got, we have 21 stacked. We'll go to 22 because Measure 22. So there it is. We stacked 22 for Measure 22. And now I have it up there, and so I can save it, and that'll be out there. Check this out on the server. Go to skytourlive.com, go down to the next section, and click Take Me to the database, and just click through. Go to the date. You'll see the folders. They look rather odd, but look for the date. Okay, it'll be 9/15, and then drill into it. And as you drill into it, you'll see a folder called Processed. It tells you right in there what to do. And Process is where this image that you're going to see exactly as this, exists. Okay, I think I just saved that twice. So we save exactly as seen. I'm also
Ray,
making Robin Curtis's job a little more difficult.
I'm sorry. Say again?
I'm making Robin Curtis's job more difficult. She's helping to tally all these things into a database for us.
Ray, we have seen another globular cluster called M46. It's in the winter sky, and it appears to have a planetary nebula inside it. It's actually a foreground object, though. It's neat looking all the same.
Yeah, we'll look at it as the winter approaches. It's actually the planetary nebula, this dead star that has this beautiful ring around it, kind of like the Ring Nebula, is about 2,000 light years away, but the cluster itself is much further at 4,000 light years away. So the star with the planetary is here, but the cluster is back here. But line of sight, they look like they're right in the same level, but they're not, right in the same plane. Okay, so this is done. This is gorgeous, and we're going to go to our 1 second night vision shot and get rid of the stack. We don't need it now. We'll clear this the next round. And okay, now let's go see what we got. That's it in 1 second at a time. See that?
Yep.
Just a 1 second exposure, guys. 1 second. You know, you can pull that away now. All right, so now let's go take advantage of another object, and that is Epsilon Lyrae. I'm excited about this. I can't wait to just try to split that. I've done it before, I think, with this telescope. And it's a wide field view, though. I did it with an f8 version of this telescope, where we have a much tighter view. But let's try it. And we're not ready for the helix yet.
I think you're going the wrong way.
No, I'm not. I'm right there.
There it is.
Yeah. I just have to swing around here. Because you know how it is. Stellarium does that zenith problem with you, you know?
Oh, yeah.
Alright, so let's get this down here. Zoom in now. And we'll find that Epsilon Lyrae is right here. That's the double-double. So let's go there. Alright, when I tell it to go, watch the telescope. Well, first of all, let me tweak it to bring back our wonderful setup, and then let's go. Goodbye to M22. Watch. Gone.
Zoom,
Okay.
zoom.
Zoom, zoom, zoom. Yeah. This square, this red square, is actually our field of view for the telescope. It's 2 degrees across by about 2 degrees across by about let's see, 1.5 degrees tall. So we're centering on the star Vega. Let's go and see. There it is. Let's bringing it in. We'll go to 33% so we can see it. Okay, how close are we? It's not bad. Telescope is right on the money. Oh, even better.
Oh.
So now it's going to take us right to... Oh, it's perfect. Look at that.
Remember, right? Vega was the star Jodie Foster went to in the movie Contact, wasn't she? Wasn't it?
I don't remember.
I think it
Wow, look
was.
at this. This is how it looks with this. Now, you know what? We're going to try and split it visually without actually taking a photograph. So we're going to zoom in on this like this. Right? And now each of those is 2 stars, correct? Is that right?
Yes.
So
They're very
I
close.
wanna-
2 very close doubles.
Yeah. Now let me see if I can reduce the exposure enough to be able to see that. And I'm going to have to come in here and let's try 75 milliseconds. It's going to get pretty dark. Let me do this too. Okay, and let's drop it even more. Alright, let's see here. Hold on. Oh, let's look at the wrong thing. Here we go.
That may be pushing it for F2.
Yeah, I agree, but
I think they're noticeably oblong.
yeah. Let me do another thing too. Let me pull this back as far as it'll go. And drop this down even more. Oh, you know what else? Let's drop the gain. The smaller the gain, the better it'll be. And what do we got? Let's zoom in even more. Yeah, I don't know.
Yeah.
Yeah,
Really
okay.
pushing.
It is pushing it, but that was a good thing to try.
Sure. But you know, while you're in Lyrae, there's another object you really ought to look at.
Oh, you're talking about the Ring Nebula.
Sure.
Yeah, I knew you were. Okay. And the drama continues at Skytour livestream. Alright, why don't we do that? Alright, so we'll come over to our planetarium program, and here we are in Lyrae. What's Lyrae? Lyrae is the harp. There it is. There's the mythological harp. Alright, and these two stars sit on either side of an object called the Ring Nebula. Now, the Ring Nebula is misdefined in their database, so when I try to go to it, it may not quite get there, but I can steer to it afterwards. Depends which one of these stars it goes to.
I always wondered if this star Spheriá isn't. You remember the Star Trek: The Next Generation episode where there was an alien species, and I think they were hung up on grammar or something, that Picard had to practice his speech to them to get it right.
Yeah.
Weren't they the ones that were called the Spheriá?
Yeah, I think so.
Or were they the ones that they were carrying the colony and the humans? They wanted them to leave.
Yeah.
One of those two was the Spheriá.
So we're centered up. Hey, there it is. Look at that. It went to Sulafat, which gives us the right object. Okay. Now this object is tricky for the following reason. We have to make sure that we don't overexpose it, because it is easy. In fact, it is almost guaranteed that you can overexpose it. It's a very bright, small object. When they're small, they're bright. When they're large, they have lots of surface area. Hopefully, if we get to see the helix later, you'll see that. The helix is going to take up 5-10 times the amount of space you see there for about the same shape. Okay. Alright. So, as you can see, this is 1 second, and it's already too bright in the outskirts. But if I get rid of the processing here, you can see that we can actually get an idea where we want to go just by doing this.
Yeah.
Okay. Yeah, so that's probably going to be about what we're going to do. And you can even see the central star, which is a white dwarf in there. Okay. So what we're going to do now is when we stack it, it'll be easy to do. So let's do this. Let's do 750 milliseconds. Alright. And we'll stack it and see what it does. First clear this. Alright, and it's right there. And it's gonna mount up the number here. So let's do that. And let's see what it wants to do for processing. Yeah. Alright, well. Let's color.
This is an object that visually in the eyepiece, it's not hard to see. It has no color to the eye, but it looks like God was smoking a cigar and blew a smoke ring out in space. Looks really cool.
Yeah, and as you can see, 750 milliseconds, 3/4 of a single second, is probably just about right. Now at higher focal length, meaning a more magnified view, this would really take on a different appearance. It'd look much more potentially rich. So it looks good now, though. I'll tell you that.
You can see the white dwarf in the center.
Yes, you can, right there. You're right. Alright. Alright, so we're gonna just back out a little. And let's see if we can do anything about helping to provide us with some more details. This might do it. Now with the Dumbbell Nebula, by doing this, it showed us the central star very clearly. But with the Ring Nebula, it doesn't. Every planetary is a little bit different, just as Daryl had mentioned earlier, and that's true. Okay.
I assume the ring is farther away than the dumbbell.
It could very well be. And a lot farther away than the helix, that's for sure, because the helix is the closest one to us.
Yep.
Okay. Well, we'll save this one, but, you know, until we have higher focal length, the ring isn't going to be terribly impressive. This is measure 57, by the way. And that's a really pretty nebula. And the colloquial name is the Ring Nebula for measure 57. So there you go. Yeah. It is just a sweet little nebula, as Izabela says. But to see its size... Go ahead.
Supernova 1987A is way down in the southern sky. We can't see it from here. It's below the southern horizon. It's in one of the Magellanic Clouds.
Yeah.
Big one or little one? I don't remember which.
I think it's... I think, you know, I don't know. I'm thinking about something right now. Okay, we're closer, so I'm going to do this. I'm going to come back in here, center on this, and readjust, get our telescope aligned. There we go. Alright, and now, from this position, we have Cygnus to look at here. Now, there was something else I wanted to do tonight, and that was a mosaic that included the Lobster Claw Nebula and the Bubble, and do that whole region. So I'm wondering, gotta see where it's placed here. It may not be perfect yet. But we could look at the Andromeda galaxy, right? I mean, I think, is that gonna work for us?
If
Not
it's
sure.
high enough yet.
Let's find out. It looks like it's not. It could be. And just to save us the trouble of the telescope trying to hunt around, what I could do is I could steer us to it and check it out, because we're going to be coming from over here. So let's try. First of all, we're going to go to maximum warp, Mr. Data. Yes, sir. All right. Did I save this yet? May not have saved this. I better save it. Okay. Okay. Right. And then we'll get rid of it. And from there... Okay. And then go to our night vision mode. And get us to 1 second from 750 milliseconds. Okay. It's beautiful. Okay. Now we'll come back here. And we're going to just pull that out. We don't need that. And I'm going to actually I'll take us to a point in space. I'll take us to this. Take us to this cluster. Alright. Just to get there. And that'll give me an idea. That'll I can get to. And then I'll see just how much further the Andromeda galaxy is. Because on a night like tonight where the sky is gorgeous, the Andromeda galaxy stands to be beautiful. Okay. Okay, so we're pulling in there. We're getting shit. And from there, it's going to drop down to that cluster. See, the back corner of the observatory there is sort of there, and it's probably not the best position to be in. But let's see. Okay. So let's see how close we are to the cluster. Make sure we got it. Looks like it right there. Yeah. So the cluster we're looking for temporarily was this one right here, and that's just about in the center. And now I'm going to steer us a little bit to the south as that Starlink goes through. Okay, Starlink, little Darlink. Okay, I'm going to change to the maximum warp. And I'll go down a little bit. Too much, I'm sure. Okay. And then we're going to come back a little bit. We're going to go back toward the east somewhat. And then we're going to pull in. See where the telescope is? It may or may not be a problem. We'll see. When you take the picture, you'll see, because you'll see it in the telescope for sure, but it might be too much of a interference with the roof of the building. We might be just too early on this one, but we'll see. Let's do this. It's definitely too early for Measure 33 down here.
Yeah.
Right,
I noted the other night, we'd have to wait a few weeks, but M74 galaxy I mentioned to you.
Yes.
That's one that Webb did the images of recently.
Oh, yeah.
If once you see M31, and then if you go to M33, M74 is about as far away from M33 as M33 is from M31.
Mm-hmm.
And it's a really beautiful face-on spiral. It's in eastern Pisces, so you'd have to wait a while for it.
For sure. Okay, we're going to dump south now a little bit.
Jupiter's in western Pisces.
Mm-hmm. Alright, so now the galaxy will be in our line of sight here. So I'm going to drop us down to a lower speed. And we're going to head to the west a little bit. There we go. And then going to go actually north a little bit. There we go. And like clockwork, our nearest galactic neighbor, the Andromeda galaxy, if you don't count the large Magellanic and South Magellanic clouds. And this is a galaxy with a population of well over 1 trillion stars. It's just a monster. And of course, it's heading right for us, and it's going to collide with us in about 2 billion years or so. So don't pack your bags yet. But it'll pass right through us and probably rip apart the the galaxy structure that we have, because it's a behemoth compared to our little tiny monstrosity that we are. Okay, I'm going to leave it here because I want to show you this area of the galaxy, but I guess I should make sure that it's centered, huh? Oops, let me go back to... Going back to this speed, make it slower. Actually, that's not so bad. One more jog.
Uberku has a question for you when you have a moment.
Hey, Mark, I was curious, and I'll drop it if it's too specific. How many stars need to be close together in order to qualify a cluster that defines a cluster? Basically, how do you define a star cluster? Actually, the way we define a star cluster is through observation and through composition. If we see stars that are near each other, let's say there's only 3 of them, but if their composition is identical, then we know they were born in the same cluster. Maybe some of the other members are gone. It really comes down to composition, Uberku. Okay? But, so visually, I mean, we could find 100 clusters just in this image, after we take an exposure. But their distance and their composition have to fall in alignment with each other. Because when the sun was made, it was made in a solar nebula, and that our star was not the only one made here. In fact, in a southern constellation, I'm not sure where, maybe Pictor or Vela, I'm not sure, they found our exact twin. It's a star that's exactly like the sun. If you put it where our sun was, we wouldn't be able to tell the difference, for the most part. So that's so the composition is the most important thing. So if you found only 2 stars, but they're right near each other and they're the identical composition, then you could say they were born in the same place together, and the rest of them might have migrated away. Hey there, Alice Pooper. Thank you. Smash the like button. Please do. I hope that makes sense to you, because in astronomy, it's never cut and dry, right? But composition and distance, 2 big factors. And the third factor is their movement. If they're moving as a group, in fact, we even have a method for determining distance called the moving cluster method, where we map the speeds that clusters are moving as a whole, because all their members might be orbiting around each other, but as a whole, they might be moving in one particular direction, while the center of mass of their cluster is moving in one particular direction, and all the stars are migrating around it. So that's also another way. So, but primarily the composition and the distance. If they're all the same,
age.
Well, if it's a cluster, if you see stars that look like they're in a cluster, the composition and their spectral type are going to determine that too. Yeah. So that's just another. Yeah, you're right. Another factor.
May I take a shot at that?
Yeah. I'm going to start the exposure here.
Uber, there are so-called open clusters, and then there are globular clusters. Open cluster, to look at, you might see a handful of stars. Say you look at the Pleiades, the 7 sisters. Well, people naked eye at least will see 6 or 7 stars. When you see a time exposure, Mark has imaged the Pleiades many times in the past. The Pleiades actually has about 1,000 stars in the cluster, hundreds to 1,000 depending on who you talk to. When you look at a globular cluster, they're much older, they're much more numerous, or there are many more stars in globulars than there are in open clusters. You're talking maybe 50,000, maybe 100,000, maybe 1 million or more. Omega Centauri down in the southern sky has 4 million stars in it. It's a beautiful object. Globular clusters are more gravitationally bound than open clusters are. Open clusters can tend to come apart over time. They just, they're not as strongly bound gravitationally, and they can tend to lose members over time. Drift apart.
The thing about the open clusters is, and everything Daryl said is true. The thing about open clusters, in addition, is that you have that n-body problem again, where stars are all migrating around each other. That's a very complex activity, and it always ends up with stars being ejected at high speeds, especially if they start passing each other closer. They start going into like elliptical orbits, and then finally they pass so close that the gravitational forces on them whip them, and it gives them enough velocity to actually leave the cluster. Like when I did my thesis in astronomy, one of the things I was looking for was B-type stars. Stars like the stars in the Pleiades are B-type stars. They're not the hottest and bluest, but they're blue. Okay, they're the next level down in temperature. And I was looking for those kinds of stars that were speeding out of our galaxy at high speed, and I found a whole bunch of them. Now, undoubtedly, these were stars that had been in clusters, formed like the Pleiades, but interacted and then went shot out and ended up heading on out. They were actually heading out of the galaxy. Now, it doesn't mean they'd leave the galaxy. It means they would go into these large orbits and maybe get captured eventually by another grouping of stars somewhere. But I don't know. This is gorgeous, Daryl.
Yep.
Looking really pretty tonight. I'm gonna.
You think the roof may impinging on it a little bit?
I'm gonna have to say no.
Okay.
I know you're seeing the yellow, but I'm not. I mean, you're looking down here.
I'm looking at the telescope. Line of sight along the tube to the line of the roof.
Let's just open that up to look at it. Okay, see now, if you got behind this, I think you might have a clear shot.
Okay.
So I think we're lucky with this right now. It's up just enough.
When we see this, folks, you're actually seeing 3 galaxies in the image. M31 is the big one. The little one, the round one, straight down below the nucleus there, that's M32. Then the one to the upper right, the oval one, is M110. All Messier objects.
Yeah, and
they are to the Andromeda galaxy, sort of like what the Magellanic Clouds are to our Milky Way galaxy. They're satellite galaxies.
And you can see also in here the dark dust. Every galaxy, most galaxies, some don't, but every spiral galaxy like this one, and we're kind of looking at it, not quite, it's a little bit tilted, but it's not edge on, but it's not flat to us, of course, it's sort of on an angle. So it's harder to see the spiral arms, but if you look down here, okay, in this region, you can see how they kind of curve around and go in the back, curve around and go in the back, and then they continue around. So this galaxy has spiral arms. These concentrations here are hot young blue stars. Okay, these are called OB associations. I see the guiding is a little bit poor here, so I want to clear this and start again, but not before I finish this. Okay, so then at the top here at the other end, we have the same thing going on. We have hot blue stars up here as well in this region, and I want to be able to show those a little better. So we've stacked 7, and unfortunately I'm gonna have to say clear. Hey, that's what happens. It only takes like 1 or 2 images to mess it up, and I know we have some wind out there tonight, because earlier I saw this going on with the 1-second exposures. Things were kind of shaking around a little bit. Oh well, hey, you know.
Hey, what? Hey.
You know, like the Jawas.
Ah, Izabela, Utini, what? Mabit.
Remember that? Jawas. Yeah, okay. Isabel, don't put Jawa language in the table of contents, please. Alright, let's see how this looks. Let's see if this is better.
And Hedrick has a question of you.
Yeah, this is... Alright, hold on, Hedrick. This is still not as good. We'll let it develop a bit. Okay, Hedrick says, Mark, would you show where we'd be if this was the Milky Way? Oh, yeah, okay. If this was the Milky Way, of course the Milky Way is much smaller than this galaxy. We're, from the center, we're about 25 to 30,000 light years out. And the galaxy is 100,000 light years across. So it's, say, from here to here. Let's say if that's the full size, it actually goes more than that. But it's like 50,000 light years, say. And we're just about 25 to 30,000, so a little more than halfway out. So we'd be right about here, or maybe say here in this galaxy if we were in the same relative position. That's a very good question. It helps to get an idea where we are in the universe in that regard. We're inside the forest looking out. Here we're outside the forest looking in. So it's very easy to see where everything is, okay? But it's not easy if we aren't, if we're surrounded by dark dust like we are, and we have bright nebulae like we do. It's very hard to see all that, It's very hard to see out of that. Let me,
We're out in the suburbs.
Yeah, we're actually in the suburbs, yeah. I want to brighten this just a little, because I'm going to take us for a little bit of a dive. Okay, right here in the Andromeda galaxy, yeah, the guiding's a little bit crazy tonight. It's not right on this particular object. The wind might be battering us out there. I don't know. Check that out. That's a little hydrogen alpha region. In other words, this is this galaxy's version of, say, an Orion Nebula. Okay, here's another one over here. Okay, see that one? All right. This is that hot blue star association called an OB association. We have a lot of them here. And these are big hot stars. When they die, they blow up. And some of this dark dust could be due to those having done so in the past. Here's another nebula region right here. Another Orion Nebula type region. And as we come up, if you look carefully, you can see them in a variety of places in here. And there's many of them in this galaxy, and they're not as obvious as the ones in Measure 33 are. Here's another one right there. Okay. This is a vast region over here of those, and another one over here. Go ahead.
I saw that OB association to the lower right recently compared to the small Sagittarius star cloud.
Okay. In size.
In size and type and what's going on there.
Okay. Well, this is the size of this OB association. It's massive.
They were talking that brighter part in particular, I think.
This guy right there.
Yes.
Yep. Well, this is pretty. I'll just let this go, even though we're getting some wind. It's okay. I don't want to mess with what success we may have here. But you can actually see here, you can see how the spiral arms tend to go out. These look like they're moving out here. And you see these beautiful realms of dark nebula. This is where it all happens. This is the seat of life in a galaxy or a universe. The heavy stars make this dust, and from those dusty realms, new stars are born, and planets from which life may spring. And we're looking at it happening live. Here's another nebula region out here. They're everywhere. The longer you look, the more you'll see.
Windy says 5-knot winds just north of your location.
Yeah, I was seeing 10 and 12 earlier.
Okay.
Yeah, well, that's all right. It's definitely stabilized because it's actually rounding out the images. Danny Johnson says something interesting that we've discussed before. He says, Wonder how many quote-unquote people in Andromeda are checking out the Milky Way tonight. That's right, and looking back at us, looking at them, and thinking, I wonder if there's anybody in that galaxy out there. Or there. Or that weird one right in front of us. And then we're looking back going, hey. Oh, thank you, Izabela, for putting that up there. That's nice. Yeah, 2.5 million light years away. What's funny is, the universe, as we've mentioned many times, is a time machine, isn't it? We're seeing this galaxy 2.5 million years ago. Look how much more pronounced and visible these dark structures are now. Because the stack gets rid of the noise that impedes our view. And now we're able to see closer, so why don't we zoom closer? Yeah, see, we got some streakies. I may need to refocus too. I do have to. But it's such a pretty image regardless, I don't want to.
Yeah. Mark,
But I have
excuse
to.
me a moment, please.
Alright, I'll save this
Yeah, that-
anyway.
All right.
I'll go to 10 here. Alright, so we're at 10 now. I will pause it. And I will name it over here. This is measure 31. So we'll call it that, measure 31. And it's a galaxy. And if I had just did it right, galaxy. And now we'll save it. And then save exactly as seen. Okay. All right. All right. God, that's beautiful. Man, that's pretty. Okay. So we're going to now clear this. Do a refocusing. And then move to try another exposure of it that's really quick, just to make sure we're looking good. All right. Okay, and take off temperature compensation on that. Temperature out there is 27.13 Celsius in the building right now. All right, we're going to focus using multi-star full width, half maximum. It's picking these stars. But what I'm going to do is I'm going to take the focus out on purpose and let it find the right focus. All right, and then we will... Alright, so now that we're there, we will scan inward and build our focus curve. Now, for those that aren't really enjoying this to the best of their desire, let me know how you think I could improve it. Because I would certainly like to improve it. You know, our poll I asked, do you enjoy Skytour Livestream live astronomy? 93% said yes, 7%, 6% said no. Over time, I think that those the people who say no or less, but I'd like to know what you think we could do to improve it. Because keep in mind, we have one heck of an investment out there to get this to work. Alright, there's our focus curve, point of best focus, and now we'll tell it to go to that best point of focus. Thank you, Hedrick, and because you did use all caps, I saw it. Yeah, the telescope will reverse images, yes. But it goes upside down when the telescope tips backwards and upside down. Like you, when you tip your head back to look upside down, the sky's upside down, but it's not reversed because you're not an optical system. But that's what we're doing there. You follow? So it does flip the object left to right, but it doesn't flip it upside down. But when the telescope goes upside down, it'll appear upside down in the camera. Okay. All right, now that we refocused, I'm going to just take a 35-second exposure and start doing that and see what that looks like. Then we'll move on. Okay, we're live stacking now. Our progress bar is this yellow bar you see way over there, right here. That bar, that as that builds up to the end point, it'll be clear. If you have this full screen, you can read these numbers and everything, and that's par for the course. So let's see what we got. All right, there we are. So let's go in there and check that out. Oh, look at that. Wow. That's really pretty. Let's zoom in again now and see how our stars look. They're still extended a little bit. Okay, so that might be another issue. Different problem. Not really a problem. A slight extension, not bad though.
I wonder.
Wow, look at that. You got a nebula within the OB association here. Look at that.
Mm-hmm.
Didn't catch that before. Yeah, go ahead.
I've heard before that globular clusters in Andromeda are visible. I wonder how you can tell those apart from foreground stars.
I think by their size. For instance, okay, like that little guy, that little guy, that little guy, that one, that's probably a globular cluster in Andromeda. These obviously are not. These are all foreground stars. But notice the difference how this looks versus this or that. Some of these, the dimmest ones, are probably the globular clusters. That's my feeling.
Would wonder.
Look at this. Oh my, that's just beautiful. Yeah.
Spectra might tell the difference. You know, if you looked at a star, you'd get a distinct spectra. If you looked at a distant globular like that, it might be a more spread out spectra, perhaps.
Maybe, but you would probably see a very simple spectrum compared to the complex spectrum with the other lines in it. So based on the simplicity of the spectrum, you could suspect you're looking at a globular cluster spectrum.
Because they're POP2 stars?
Yes, because they're all the same. POP2 means older. Look at this. Focusing did wonders. Look at that. Look at that beautiful, beautiful arch of hot blue stars. Isn't that pretty? We can see a nebula right there. There's a beautiful nebula right there. In this OB association, a nebula in here, nebula in there. That looks like a big arch. And you can just sift through the Andromeda galaxy and see amazing things. Look at this beautiful H2 region right there. There's one right there. There's that maybe a foreground star or not. That's definitely an H2 region there. This is
There's an
That's an
H2
H2
region that
region
really
there.
stands out to the lower right of the nucleus.
Yeah, that's that little. Is that the little one we talked about?
Yeah, there's one I think you pointed out earlier.
Yeah, that was the wispy one. And that is.
There's a very red one over there. About a little more than halfway up on the right-hand side, just above that star.
Above what star? This one? Where?
Farther to the right.
From the. Oh, this one right here.
Yes, in that dark cloud.
Yeah, and this might be a supernova remnant right there. Along with
green?
this. Yeah. Okay, that's really pretty. And just talking about this, we've already stacked 7 more. Now, just to see what we could do with this, I could do this to try and soften the noise a little bit. So you watch what happens now. Okay, now I'm softening the noise a little. Alright. And this is Mesher 32. This blue, sharp blue, this sharp red, and that sharp green, that's the blue. That's the guiding error on errant pixels for this particular shot. Now Hedrick asks, wow, how close are the stars and I don't know what you missed type. Oh, how fast in the center. How fast are they moving? Well, that's the interesting dilemma about galaxies. Look at this nebula, this extensive. That's like the size of the Carina Nebula here. And here. The stars that are moving in the center, oddly, if I back out to show you, are oddly moving at around the same speed to orbit the galaxy as those here. The curve is not flat, but it's almost flat. It kind of goes up in a gradual arc when it was expected to be a rather sharp cutoff. Like Mercury zips around the sun at high speed, and Pluto lazily goes around the sun in hundreds of years. So Pluto does it in 88 days. So we thought maybe galactic stars orbit that same way. But no, they don't. Galaxies rotate effectively like a rigid disk. Not exactly. There's some lag, which is why spiral arms are swept out like they are. But it takes billions of years for that to happen, or they would have wound up by now if they did it the normal way. So what's going on? And what's keeping them rotating at almost like a solid disk, effectively? And that's where dark matter comes into play. Matter we cannot see and that we don't understand fully yet, which is why we call it dark. We don't understand it. This is really... I've never seen it like this before. This is really pretty. Wow. I think this is a contender for the next best Andromeda image we took. Look at these OB associations here. These are magnificent. Wow. I don't know.
There was a cloud up at the upper left part that you were just on a minute
here?
ago. It looked like it had a lot of detail to it. Yeah. Just about dead above your pointer to the left.
Oh,
to
right
the right.
here.
Yes, that.
Right there. Yeah. Okay. Let's zoom
Can
in.
you zoom in on that anymore?
Oh, yeah. Look at that. This is incredible. We're literally looking 2 million years into the past at a galaxy whose structure has undoubtedly changed a little bit since we saw it, since we've seen it. Here's a nebula right there.
Quite a H2 region to the lower right of that, too. That big red splotch. Yeah, right there.
Yep. Well, don't negate these star clouds.
Oh yeah.
These star clouds are just amazing. Oh, to live in the Andromeda galaxy. Look at this. Look at this beautiful nebula complex.
Mm-hmm.
Yeah. Let me see if I can bring that back a little now that we've... Yeah. Let's add some darkening. And check it out now. Wow. This is really something. Really something. We've never seen the detail in the center like this. Look at that. That really sharp detail in there like this. We've never caught, well, we've seen these, but we haven't caught this sharper detail. Here's the nebula you called out earlier inside the dark nebula. That's an Orion type nebula inside of another dark molecular cloud, undoubtedly. Same here. Like the cocoon or like the Orion Nebula. Wow. Okay, Hedrick asks, what is H2 again? Oh, certainly. Let's take the Orion Nebula and let's take the Orion Nebula and then take this right here. Okay, this is a red glowing gas, and that red glowing gas is due to energetic stars that are ionizing hydrogen gas nearby. That ionization causes the hydrogen gas to glow red, and so we see that, and we call it H2 for hydrogen alpha, and it's part of the hydrogen atom's normal abilities to do this ionization, and it's called recombination. When the electron comes back into the atom after it gets ionized and out of the atom, it gives off light, and that light is this characteristic red color that we see. Welcome to the astronomy world. Welcome to the universe. You know, cosmic ray shows the JWST version of the Andromeda galaxy.
Yeah, I'm looking at that now. My cup runneth over. I can't keep up with all the stuff coming out from the web.
That's all right.
Cool pick.
Neat. JSCO said, Mark, many images we see seem to be getting better. Is it just good luck with sky conditions, or can the scope improve itself? Yeah, the scope can improve. And I'm working actively to make the scope improve. Before I came on, for instance, tonight, I started recalibrating and doing calibrations of the guiding system to help that. Same with the focusing system. And so this gives us the opportunity to see better objects, yes.
Look at that one right there. Yes, that.
Yep. This is the one I pointed out earlier. It has this beautiful reflection nebula behind it. That's gorgeous. Man. So yes, our telescope does improve, and the sky conditions also help us, certainly. Speaking of sky conditions, let's do a quick acquisition here. If our camera shows us what we're looking at.
One thing I think you're going to see now more this time of year is you may need to refocus more often because you're getting a greater temperature swing.
That's correct.
I saw in the forecast earlier for Wickenburg that it's cooling off quite a bit at night down there now.
Yeah. Well, we went from 33 Celsius to 27. That's beautiful. So we're actually looking at the Andromeda galaxy, which is up in the north, which is northeast, so it's about around here. I can't really see it on here. Let me see if I increase this. It's not that, no. I can't really tell. Wait a minute. So, yeah, it's going to be over here, just around here somewhere. So that's kind of where we're looking. But now we're going to try and see if we can look at some things here. Directly overhead. The sky is... looking at this galaxy, holy cow. It's cooperating so well. Wow, look at that. I'm really happy with this. This is just stunning. Look at that. Wow. Let me color correct to make that final, beautiful view here. Wow. Now that's really something. Okay, this is 23 stacked. We'll go to 24. Izabela's going to have a good time with this one. Okay, there's 24. We're going to pause it. And measure 31 galaxies, all defined. Save. Come back. Where are you going? Save it. Okay, so it's saved now to the server. So again, for those that don't know or remember, every time we take a picture, it goes basically off this site here, skytourlive.com. And when Izabela or Daryl put links, they're putting a link directly to the database so you can see it. And so that's one of those things that you can then download this image as in high res, just like we do, and just like we create it. That's 4,400 pixels by 2,300 pixels. It's a big image, bigger than most screens that people use. And you can go sifting through the galaxy for hours, looking and learning and seeing new things. And every image we take of the Andromeda galaxy, if you compare them to each other, you might find something that's not there, and then you go in the history books. Okay, pretty cool. You just need a little bit of you need something called a blink comparator, which is not hard to do with simple photo analysis tools now. Okay, we save this, and we're going to come back to our 1 second night vision enhanced shot. There it is. All right. Now that we're at this end of the world, universe, let's see what else we can look at. I wanted to do this last time, but I didn't. And I'm thinking we can do it now. Maybe. Let me steer to this and see if it's going to be all right. Let me, first of all, let me just pump us a bit just to get that. And now we will go and do a max. We're going to head north a bit. So here we come. Here we go. I guess we can see it. Okay, this is going to be this is another nebula that we have imaged in the past that is actually quite nice. And you'll recognize it in just a sec. Well, you may not recognize it, but you'll understand. Okay, let's go back to here. And go in here. Okay, and now let's just pop it up a little bit north again. Okay. And here we are. So we're going to center on this guy. All right. And now, again, I'm just driving there because it's so close. All right. And we want to go a little east. Okay. Alright, now, before I tell you what it is, I would just like to get an exposure running on it, and then you tell me what it looks like. Alright? Tell me what it looks like. Alright. So, we're going to do this, let the search get going, find our guide star, and this will be, again, a 30 second exposure, actually. 30 seconds. We're guiding, and I'm just going to let it stabilize just a little bit. Okay, wait a second to let it stabilize. Okay. And now we can progress. And we're doing 30 seconds. That beautiful nebula should be up there now. This galaxy should be up there now. Now, this is in the buffer. The sensor on the camera is getting all new information because it was cleared. Alright, now I'm clearing the buffer so that when the camera's finished with the exposure, it'll read out the buffer and put a new, or read out the sensor and put it into the buffer. And there it is. Now, to get an idea what this is, you have to turn your head about 40 degrees to the right. So you look at it on an angle. Okay, look at it on an angle. Kind of like at this angle, turn your head like that angle. And what does that look like? Anybody? Just put that in the chat.
I know, but I'll keep it to myself.
You have to.
Yeah.
Yes, teachers don't often give the answers, you know. Alright.
I'd make the sound if I was any good.
I know you're gonna say it, and I was thinking.
Izabela and JSCO got it.
Oh yeah. Oh yeah, that's the sound. Waka 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 waka. That's the Pacman Nebula, in fact. Exactly. Oh, sorry, Izabela.
She just knew.
Yeah, she's good. She's come a long way.
She has.
Yes. Yes.
We have brought her over to the dark side of the Force.
Hey there, Angry Santa. Waka waka, you're right. It's the Pac-Man. This is looking really pretty too. Look at this. Lots of detail in here. Let's find out how much more there is. This might be a blowout, but let's try it. Okay, well, that's not so bad. You can see there's more out here. And if we blow it out even more, let's see what that does. Okay. Now we'll bring it down. And then come down to our system here. Do a color correction. Alright, and yeah, there we go. And let's pull this in. These vertical yellow lines, this is the data right here. This is the RGB data from the sensor red, green, and blue. Together they make a color image. Well, this is the black level. If I take the black level to the left, we get more lightness, okay? If I take it to the right and it starts to hit the curve, it very rapidly gets very, very dark. Okay, because we're starting to cut off dark, and now at the peak here, this is the maximum of the curve. So we're losing half of the black data, actually a little less than half. But if we come over here, now that's most of it. And then this is the mid-range, and now if we bring this curve over, you'll see that this is all guiding that yellow curve right there. All right. And the idea when you're doing processing is you don't want your curves to get too close to each other because you're losing lots of data. So you come out like this, right? Come back a little bit to right about there. And now you can play a little bit with this to get more data. But you don't want to saturate, you don't want the bright, spots in the nebula to go so bright that they can't go any brighter. That's called saturation. We don't want that. So there you go. This is the Pacman now. Let's come close. Look at that. Wow. Not bad.
Bit of a
Let's
chunks.
flip that nameplate out there. What's that?
Bit of a chunks in there.
Oh, right here?
Oh, all through that.
Yeah. Let's see if we can drop the noise a little bit and come back to it. Okay. Let's drop the noise a little bit in here. Okay.
The red in the
Not
clouds
bad.
over on the left. Some look like pillars, sort of, like in
Yeah.
the eagle and such, and dark clouds floating in front, and
Yeah.
an
Here's a
interplay
pillar
there
that-
where the Pacman's mouth is.
Yeah. That's what's really going on there is there's a dark nebula way up here in the front, and there's a bright nebula back here. And that dark nebula is blocking some of that bright nebula, and that dark nebula is this. And a little bit of this, all coming down to here. Lex, that's a pretty interesting story. LDS, you're funny.
As
William
I say
Shatner.
farther down, that was a Star Trek 4 reference.
Yes. That was Star Trek 4. That was the Save the Whales episode, wasn't it?
Yep.
Yeah.
Kirk and Spock are
Captain.
sitting in Catherine Hicks's pickup truck, and
Yes. He
I
said
forget what
too much,
prompted
he did
the
too much LDS in the 60s.
Catherine Hicks gave him that funny look when he said that.
Like LSD? Let me pull the nameplate out, guys, because you don't need to see that now because we're looking at the beauty of the nebula. Yeah, I remember that. Okay. Let's... do that. Wow. So what do you think of the Pacman, guys? Let me show you a little close-up too. As Daryl alluded to earlier, there is a section in here of the Pacman where you can see a bunch of these pillars. Now there's a hot young cluster that's formed here, and that radiation is going out in 3 dimensions, coming toward us, going away from us, going out to the sides, all directions. And so when it hits this gas, the solar wind, that is the stellar wind from these stars, erodes the gas away. And the natural thing that happens is in areas where there's a density of material is they last longer than the more less dense stuff. So that knot stays and shields the part behind it. So you get like a stalk, like right here.
Yeah.
Okay, this is denser up here, so it's eroded away around it, but this part's still pretty dense and hasn't allowed that starlight stellar wind to erode it, so it protects what's behind it a little bit, and you get this stalk.
Yep. And you see that
And
it's
they'll
pointing
tend
right
to be
toward the
radial.
star cluster in the middle.
Yeah, that could be real or just a line of sight pointing, but it may very well have something to do with what's going on. But we see that a lot. We see that a lot, and you notice it's radial. See, like this one's going away, this one's heading away, this one's heading away. Okay, this one's heading away. These are heading away radially, so there is something to this. Okay, I can't see what's going on behind this area here because it's blocking what's going on behind. There might be pillars back here that we don't even see. But there you go. That's the beauty of astronomy, studying this stuff, trying to get the answers. Now the actual size of this is just about like that, okay, in our sensor. You had 4 full moons across, 3 full moons tall. Starry region. And we've
Hedrick
done
has
20.
a question for you.
Okay, let me pause first. And now I'll change this to Pacman. I'll be right to you in a minute. Hedrick. Nebula. Okay. And now let me save it. Take care of that. So we're going to save it. You see a green bar that's telling us it's on its way to the server. And then the ping file. The actual file. Okay, what's Hedrick have to say? Do you sell a photo book? Actually, not yet, Hedrick. I mean, we thought about it. But we do, if you go to skytourlive.com, you can actually buy prints of everything we do, but they're highly processed prints to bring out even more detail than you get to see here. So we spend the time to add a lot of additional processing to pull out much more, because there is a lot more data behind the scenes. And, it's just, you can see how gorgeous it looks. Just imagine it even looking better. So we do sell them, but we are thinking about we're thinking about a photographic book, but we had to acquire a lot. I'll give you an example. In our database that Robin Curtis is compiling for us, we're up to like almost 700 photos that we've taken. Now, a number of those are the same area. So if you take away that, the number of unique things we've taken pictures of are a number at about 400. So I was astonished to see just how many things we took photos of. I didn't think there were that many things in the sky. But, from clusters to globulars to nebulae, we have really taken a bunch of images,
Have you copyrighted your images?
Yeah, they're all copyrighted. And I only started doing that lately because when I say free, I mean free. The ones that go up to the server, those are free for use. But the ones that end up being sold as photographic prints, there's a copyright on the lower right corner.
Well, his next question makes me wonder about that. Can he send the images to Shutterfly to make a book?
I don't see why not, but the thing about the images is that the processing is not nearly as good as it's great, of course it is, but the thing is it's going to have to be kicked up quite a bit. You don't want any out of focus images. You don't want any images that have slight degradations, and you want the best possible images to go into print. So if you look at our print site, if you go to skytourlive.com, you scroll down to the first section, and that's to get to the database where you can take down these pictures for free. The next section down is to the photographic print page, where you can get canvas prints, paper prints, prints on aluminum sheet. I mean, it's crazy. And those photos that you get on the aluminum sheet, on the actual prints, those are the ones that are fully processed to bring out the absolute best of these images. And I have to say, in some cases, it's night and day. But that's okay. But like I said, whatever we produce for free, I can't stop anybody from doing that, because I made the commitment and the promise to spread the word about astronomy. So
Well, that's why I asked you about copyright. I mean,
well, the images
downloading
are
for personal use is one thing, but if somebody's going
right.
to take your pictures and make a book with them without your express permission,
Well, if he
maybe
makes
a
a
different
book
matter.
if he makes a book for himself, I don't care. You know, but if he's gonna make a book to sell, well, you can't do that. Daryl's right about that. Those are our property, yes, for that thing. So,
I
well, if
mean,
you want to
yeah,
talk to me,
okay, and then in that sense, these are private property.
if you're using it for your own self, yes. I mean, it's a gray area, right? Yeah. See, now he said, I mean, if you made the book, okay. I'll investigate Shutterfly. I've seen the books. I've gotten books in the mail from people who've created Shutterfly books, and they're kind of cool. And I'd like to, see. I mean, I have a book, right, The Populated Universe, which is 375-page long book on exoplanets and life in the universe that I wrote, and that's copyrighted. And the photos I made in there, I actually put images from SkyTour Livestream East, and I made my own images as well. Renderings, computer renderings, and those are all copyrighted. So I've been through that before, but I think I think that what the key here is, what we produce, you can put on your personal machines. You can take it down, use it for anything you want, except to go make yourself a book that you can sell for yourself. If you wanted to do that, we can talk about that. I know you didn't mention, I know it's not what you meant there, Hedrick, and that's cool. But if you wanted to do something like that, then we can talk about what you would make, what we would make, But, be prepared for the fact that we would get the lion's share of that profit. You get a piece of it, because unless you're doing the work at the bindery, putting the book together, those photos still belong to us in that regard, if you're going to do a mass consumption book.
Maybe this is what you need to think about for your next book. Take your best prints and your best images and make a coffee table book. Sell it yourself.
Well, I'd like it to be in like a Amazon or Barnes and Noble or something. But,
sure.
People tend to like to buy electronic books too. But when it comes to stuff like this, there's nothing like having a gigantic, oversized book that you can just look at the pictures, and then on one side of the page it discusses what you're looking at and gives you all the science behind it. On the other side of the page, it's just a beautiful picture. So you take what you need and leave the rest, right?
Yeah. Astronomy is one of those things, though, that, like you mentioned, electronic books. I mean, if you want to see a book that dates quickly, go buy last year's computer books. I mean, they're out of touch. They're out of, they're obsolete already. And I have some old classic astronomy books, picture books, Galaxies by Timothy Ferris, for instance. And
oh yeah,
I haven't looked at that in a long time. I mean, it's still a pretty book to look at. But the images, I'm sure, are obsolete by today's standards with the modern instruments and imaging techniques and all that.
Yeah, for sure. Okay, we did 20 images here. I'm going to save the Pacman here. And I think I did this already, so it might be up there twice. I apologize to Robin Curtis, who's probably now asleep. So I'll do it since I know she's asleep and won't yell at me. Okay, so that's up there, and we can clear it. And then go out of here, go into our 1 second.
You talked earlier tonight about doing the bubble and the lobster claw again. Are you going to do that tonight or another time? Dark of the Moon?
I was thinking, yeah, that's the other thing I'm about to do. Okay, see what the sky looks like right here? I gotta make sure that we're not looking at moonlight coming up. So let me go check right now. It looks like it's 10:08 out there. This is earlier, and let's do another acquisition. And it seems the camera's working nicely, so maybe it'll just keep going. This particular camera is a long way away from the observatory. It's sitting out on one of the arms of the take-up rollers for that size. Yeah, the moon's coming up. See it? Boom, boom.
Yeah.
Yeah. Well,
Hedrick, we
Yeah,
won't
so
see
this-
the horse head for a couple months yet,
yeah.
unless we pull an all-nighter. Orion's in the morning sky right now.
Yeah, I mean, hey, you know, maybe, you could convince me to do an early morning stream. I used to have the midnight to dawn shift in the observatory that I worked in, and it was always the coldest shift ever, because it's actually coldest actually just before dawn. Just before the sun becomes, starts to heat the atmosphere over your head and it comes down. So, I had one professor who told me 6 minutes before dawn, the official dawn, I mean, you'll see the sky lightning, but, a little bit, but 6 minutes before dawn starts, take the temperature inside the observatory, because that'll be the coldest part of the day. Okay. And over time, it turned out that that was correct for that site, Okay, so we're at the point now where I'll shut down the all sky. We know that it's running. And I'll bring up the planetarium program. I'll wait for the dark of the moon to do that other one. But I will do, since we're here, I think I will come over here and do this Gamma Cast Nebula. What do you think of that, huh?
Somebody wants to see the double cluster.
Oh, I know. But we can't see that yet. That's down here.
Yeah.
And it's right there. And I don't know that we can get to that yet. If you look where the telescope's pointing, it's got to go substantially lower to see the double cluster. Don't worry. We're going to see it. And when we do, we're also going to pick up the Heart and Soul nebulas. And when you see those, you're going to be astonished.
Yeah.
Those are
Somebody
beautiful.
asked for the heart earlier, too.
Yeah, we're going to get there. We're going to get there. We can't rush the season, but I like to. Double cluster is stunning. Now we're up here right now. So let's just first of all, we're going to go north some more. So we're going to do that. And what do we got for speed? 0.25. Okay, let's try that. Go north. There we go. And away we go. Okay. Now Navi actually is the name of the star here. And Navi is really bright. Okay, so it's gonna cause issues with the nebula we're trying to see. But that's okay. We're still going to try for it anyway. And of course, that's Navi right there. Alright, so we're going to go a little bit west right now. No, sorry. I was right to go east. I was thinking the wrong thing. Okay. Let's zoom in on this a little bit. That's what I was looking for. Alright. So, there's a nebula here that I want to check out. And to do it, I've got to do this. I might be able to... I don't want to, but I might be able to put the star just outside the view, but we're going to get a big bright thing here. But let's just try it. I believe we're right over the nebula right now. Yeah, it's a beautiful nebula. Okay. Navi, yes. Terran Ray. Yeah, uber cool. I used to, in that third shift in the observatory session, most of the time I was actually working on taking images of stars that were very, very, very difficult to capture. And it was for working on the parallax program, the study of the nearby stars to gauge their distance. And we actually had to make sure the telescope was perfectly following the guide star, and because we had to do it manually. And again, the telescope was 35 feet long, weighed several tons, and it was the whole floor moved up and down to meet it. It was so big, and that's crazy. All right, let's do a 35-second shot here. I'm just gonna change that to 25 seconds actually, and let's go and see what we got here. Now let's look at our live stack to capture the data, Mr. Data.
Be right back.
All right, be right here. Oh, let's see if I got it right. Oh, I did. Look at. Okay. Okay. I'm just going to reposition the telescope and start taking pictures again. So, enjoy the music. Okay. That should be good. I'll let it stabilize. I'll check the focus. Looks nice. We used to listen to classical music in the dome, or any music, because domes have this peculiar way of bringing the sound all to the center. It sounds like you're being surrounded. It's the original surround sound, I can promise you. The most amazing sound inside those buildings. That's one thing that I do miss with the bigger dome. Okay. Now we can do a 35-second shot here. Get out of that. And we're going to take a picture of this beautiful nebula. Which is right here. I'm going to clear this. So We're taking a longer shot now. This will be the last nebula for tonight because we're losing our beautiful dark night. Yeah, well, there's that. I gotta fix this. There we go. Ah, look. That's the Gamma Cast Nebula, Emission Nebula, and Reflection Nebula, all in one. Okay, let's color correct those curves, get them aligned. There we go. See, when you color correct, you notice how more stuff shows up? That's beautiful. All right. So we're taking a picture of this nebula that is around Navi, which is Gamma Cassiopeia, and it's called the Gamma Cast Nebula. Kind of like the Mama Cast Nebula, but Gamma Cast. So it's an emission nebula and a reflection nebula.
Grown.
What's that?
I said grown. At your Mama Castro.
Oh. Okay, pull that out of there. And we're gonna try and make that a little brighter. Now look at. You'll see that this reflection nebula, which is dust that's scattering the starlight from the hot star, possibly Navi or other stars nearby, is rimmed by ionized hydrogen that is also mixed into this cloud. And here you have this really interesting interplay between a reflection nebula with a edge, like an embossed edge of hydrogen gas. Really fascinating. Yeah. Let's see if we can do a little work on that. I think we can. Let me kick on the bilateral filter. It'll soften some of the noise. Yeah. Soften some of the noise. If we turn it off, you'll see a difference. See how it's sharper, but you know, that's okay. Navi's a bright star, as you can see, and it's a blue star, so it's hot. Now that we have some better techniques, we can probably do a far better rendering of this nebula here. We've taken it before. Yes, Mama Cass, she liked to eat, but I don't know if that's what killed her. Was it a heart attack that she had? Or did she choke?
It's been a long time. I think so. I'd have to look it up.
Yeah.
Yeah, she was a big girl. Quite a singer, though.
I think she had a trumpet of a voice. She was really good. Look how this is resolving. This is a beautiful nebula.
And Michelle, what was her name? Michelle Phillips? She was the other female singer in the Mamas and the Papas. Did you know she was actually in Star Trek The Next Generation? One episode.
No.
Yes, she was.
Yeah. What'd she do?
Oh, she was a guest star on one episode. I'd have to look it up.
Here's where we are, just so you know. The Gamma Cast Nebula, the Emission Nebula, and a Reflection Nebula. Here's the emission part. There's a reflection part up there. Little additional reflection here. There's some right there, a little tiny spot of it. It's mixed all throughout. This is a very complex region. And so what we do is we actually remove the stars from the image, and then we process only the nebula, and then we put the stars back and make it so you can put them in, take them out. Here we're going up on 12 here, 12 images stacked. Again, stacking is making an image sandwich of previously aligned images which align to form a stack. And what that does is it eliminates all the noise over time between the stars. Remember, we do our 1 second shots. You can tell it's 1 second not by looking at the stars, but by looking in between them. You see the green noise changes every second. Well, that averages out when you actually do a stack, and then it's easy to remove. I just yawned, sorry.
Michelle Phillips appeared in the Star Trek The Next Generation first season episode, We'll Always Have Paris. She portrayed Janice Mannheim. She was a scientist, I think, and she might have been an old love object of Picard's, I forget. Let me look up her character. She was the wife of eminent scientist Paul Mannheim.
I remember that.
She was in a romantic relationship with Jean-Luc Picard when he was in Paris.
I remember that.
He was supposed to meet her at the Café des Artistes on April 9th, the day before he was due to ship out, but he never showed. After waiting all day, she attempted to track him down, even looking for him at Starfleet headquarters, but learned he had already left. She continued to think about him from time to time. And I'm trying to remember what her husband did.
Besides try to kill Picard?
Her husband had opened a window to another dimension, causing the death of his entire team and nearly his own. A distress call was heard by the Enterprise D, bringing Picard back into her life. His crew put a stop to the Mannheim effect, and she learned from Picard that he was too afraid to meet her that day in Paris. Let's see. Paul recovered after the Mannheim effect had been ended. Upon his recovery, Paul said they needed to return to the planet to continue the work they had begun to honor those that died. She agreed to stay with him on Vandor 4 as he continued his work, and he promised that upon their return to the planet that their relationship would improve and be different. She said with a smile that it always is, my love. This time, however, she got a chance to say goodbye to Picard. End of story. Michelle Phillips is 78 years old now. Huh?
Who wrote that? Was that Brandon Braga?
This was first season. I don't think so. I think he showed up later.
Okay. This is beautiful.
I'm looking for the author.
Imagine sailing through this nebula, going over this ledge, and going into this abyss in here, going behind this dark nebula, out of sight of your world forevermore, and then coming out on this side of it. This and this are at the same level probably, and this is overlying it, this dark dust. I can see this in 3D for the first time. I've never been able to do this before with this nebula. Really, really nice. Wow. Well, Dot Fontana wrote that episode, according to Donald. Possibly. DC Fontana.
I'll take his word for it. Kind of getting lost at the memory alpha site.
Hendrick
Thank
says, is the Evil Nebula Pillars of Creation up? It may be still, but it's getting low, as is my energy level. So this is going to be our last object for tonight, guys. I'm sorry. But as it turned out, I wasn't going to be streaming tonight. Then I realized that everything that's taking place, the wedding that my son is in, or he's getting married, so I guess he's in it, is at 3 p.m. tomorrow, so that's fine. Taryn Marie, I'm down for a lifetime space trip. You might get really bored. There's no internet out there. Starlink doesn't work out there, Taryn. Hedrick, you're welcome. Awesome space traveling. We loved having you. Okay, we're at 22 images here. I want to go a little more, soften this up better, and let's see if we can work this out better. Okay, gotcha.
I always thought season 1 of Star Trek Next Generation was incredibly lame, except for the last
me
episode.
Too. I didn't like Encounter at Farpoint.
No, I didn't like any of it. I know they said Picard or Stewart kept his bags packed for the first 6 weeks. He didn't know if they were going to make it either. The only one I liked was the one with the little creatures that were burrowing into people's heads, and they were trying to take over the Federation. They looked like little... you know what I'm talking about?
Are those the things that Khan used to get the ship taken over?
No, they were...
Make them malleable?
There were a couple of episodes about it. One was the lead up, and then one was the main show. There were these little critters. They looked sort of like little fat scorpions crawling across the floor, and they burrowed into people's necks and left a little gill thing sticking out the back.
Oh.
You could tell you were possessed by them, and they had taken over Starfleet Command, and
and they look behind your neck and
them. Huh?
Yeah, I remember that. They saw the gill thing sticking out of the neck.
Yeah, and the end of the show, the one guy was sitting in this sort of chair contraption, and they shot him.
Oh, I remember that.
With a laser until he blew up. That show was considered so graphic at the time that the BBC banned it. They couldn't show that episode in Britain.
Right, but Monty Python can have the scene of the guy in the restaurant saying, "If I eat more, I'll explode." It's wafer thin, and he pokes it into his mouth, and as he pokes it to his mouth, he dives for cover, and sure enough, the guy explodes. Guts everywhere, and you see his open rib cage with his heart pumping, and he's just sitting there going, ugh. Okay, and everybody's covered with guts. That's okay, but you can't show that. It's weird. I guess it was a parody, so.
Yeah, I remember.
What do you think, guys? 26 stack. This is gonna make a beautiful, beautiful result. We'll get rid of the halos. That's 27. Okay, we will pause it here, and I'm going to name it the Gamma Cast Nebula.
That one's nice and subtle. I like that.
Well, it needs to be loud and obnoxious. We'll make it so. Make it so. Make it so, number one. I remember Jonathan Frakes. He looked like such a little kid at the first season. You know, clean cut, thin.
Yeah.
And
he
by
grew
the
beard
by the last, and he grew his belly too. He ends up getting pretty big.
Yeah.
And then he, I mean, if you ever have you been watching the Picard series on is it Paramount Plus?
I've never seen a bit of it. I am not interested in any of the new Star Trek.
Well, that's
not
Next
Picard,
Generation,
not Discovery, not Strange New Worlds. I saw a little bit of Strange
well,
New Worlds on YouTube, and if I was, who was it, Captain Pike on Strange New Worlds?
Yes.
His crew is entirely too lippy. I would have told him to shut their mouths.
Well.
Then I didn't like the first Star Trek reboot either. The J.J. Abrams one. I've never seen any of the other ones. He took liberties with canon, as the saying goes, and those who try to defend it say it was an alternate timeline. That's a bunch of crap. I mean, you're not the new guy on the block. You come in and you decide to blow up the planet Vulcan in the very first episode. That's kind of pushing things. I thought that was extreme.
Yeah. All right, guys. Well, we've done it. We've come to the end of the stream tonight. I hope you guys enjoyed it. According to the survey, 90% said yes, 10% said no. I'd really be interested in who said no and why. I don't need to know who it was, but I just need to know why and what the problem is that you found with it.
Are you where that came from?
Yeah, I created the poll.
Okay, I came back from when I left and saw that in my chat box. I didn't know what was going on at first.
Well, we had 48 votes, so that's pretty good. Magoo, you've done it again. Well, yes. Oh, yes, indeed. And the guy that played that was Thurston Howell III, Jim Backus.
That's right.
Yeah. Okay, guys. This is good. This is up there. We are golden. So, thank you for attending this stream with us tonight. Enjoy your company as always. And tomorrow night probably won't be a stream. So therefore it's going to be the clearest night of the year. No, I'm just kidding. I don't know how it's going to be. But we will return probably maybe Sunday night. Uber Crew, you're welcome. Well, you're welcome to all of you guys. I really enjoy this. Yeah, nice. Well, like I say, you take what you need, leave the rest. Oh, yeah, of course.
All right.
All right, guys. We shall see you, and we will talk, I guess, as soon as we find our way to another clear night when I can do it. And that'll probably, like I said, probably Sunday. Okay, there's the music. You know what it means. All right, guys. Have a good night, and we will talk soon. Good night, everybody.
Night.